Yes, welcome back again. Yeah, this is Richard, and the channel is Physical Sciences Silver Bullet. Like I always tell you that we have reasons as to why we started with this before we do questions. Trust us that whatever we are doing it out of experience, and you'll start to benefit out of it better than when we would have started with questions. Okay, let's start with this. This is one of the applications of electrolytic cell. And also, please, before we start, don't forget to subscribe. It's very important that you do so. And also, you like us. Click that like button. It's waiting for you. Okay, electro-refining, good people. What happens here? Okay, it's very simple. Why you have a trough or a container which will form our electrolytic cell, you have an impure copper, and you have a thin sheet of pure copper, thin sheet of pure copper. Okay, there are reasons as to why we make it thin. Because it's going to become big. So if you put a big one, then it might be too heavy. So we put a thin one because through the process, as you are going to see, it will gain mass. So let us look at the principle. The principle for electro-refining. First of all, this is impure copper. Impure copper. Now, if you are going to purify copper, one of the fundamental principles is that this solution must be soluble copper salt, preferably copper 2 sulfate. Okay, what else do we have to remember? We have to remember that this one has to be pure copper. This is impure copper. Now, what is missing is the polarity. And the polarity comes from intentions. What is the intent of this setup? It's very clear that copper, which is pure, is going to come out of the impure. It comes out as copper ions. Remember, whatever is moving here are ions, and also become deposited on this thin sheet. That intention gives you the polarity. How? Let us look at it. You have to remember the mechanism of conduction. The positive move toward to negative. So what does that mean? It means this side is negative, and this side is a positive. So this is positive, this is negative. Don't forget that I've got this a polarity from the intention of this setup. Okay, what comes next are going to be the reactions which are going to take place. Okay, let us squeeze them here. Okay, yes, suppose we have our cathode. And the cathode is the thin sheet, thin sheet of copper. And what happens there? What happens is that copper ions are moving there. And when they reach there, they become reduced. They take up 2 electrons to become what? To become copper solid. Okay. Let us also see what happens at the anode. At our anode, this is what happens. This is our anode. and the copper is being oxidized there. So what happens is that the copper anode, but only the pure part of it, becomes oxidized, losing those 2 electrons. So these are the 2 reactions which take place. And these reactions, they resemble something we saw somewhere. Okay, let us see what happens. Then comes the net reaction. We saw that at cathode, 2 copper ions took up 2 electrons to become reduced to copper solid. And at cathode, there was oxidation of copper, giving you 2 copper ions plus electrons. When you get net out of this one, it's the same situation. You cancel out the common electrons, but this one is also common, and this one is also common, giving you what? Giving you net reaction 0. And at this point, you are going to answer this question. What is the effect on the electrolyte every time you see this situation? What's the effect on the electrolyte? You have to have the capacity to answer that at the moment if you have been following us. But now there's something we have to look at. Observable changes. At what? At, okay. At cathode. Okay. To predict this, you need the equation. The equation says that at cathode, copper ions took up 2 electrons to give you copper solid. Now, I want you to remember that every time you see this as the product anywhere, this means that increase in mass. So our cathode increases in mass. Okay, let us go to anode. We must not forget this. At anode, what happened at anode? Oh, copper became oxidized. It was supposed to be copper solid, losing 2 electrons to give you 2 copper ions. And I want you to remind you that every time you have this one on the reactant side, it means decrease in what? Decrease in mass. So that's what happens at our electrodes during electro-refining. Now we need to conclude this setup with this information. We need to remember that the intention was that the copper ions moved, and that one gave us the polarity, whereby this side became negative, and this side became what? Positive. But there's something I want us to know. During the time when copper is busy, copper ions busy migrating to the anode, the impurities fall down here. These are impurities. Actually, we call it what? Sludge. So as the process proceeds, we see impurities settling on the bottom of the trough or of the cell. Now, these impurities, we don't just throw it away. It has some importance. So, importance of sludge. What's the importance of sludge? It contains precious metals like platinum, and gold. So we don't just throw it away. We process it further for these precious metals. That's the end of electro-refining. I would like to remind you that you need to subscribe. Okay, people.